In Electronegativity Part 1 video, we discussed in detail meaning of electronegativity and polarity with plenty of examples. We also did difference in electronegativity and electron affinity. In Electronegativity Part 2, we discussed the factors controlling the electronegativity, in which we discussed in detail variation of electronegativity with atomic size and variation due to closeness to the noble gases. Why metals have very less electronegativity and non-metals have high electronegativity, followed by plenty of practice problems and an interactive quiz. In Electronegativity Part 3 video, we will identify which element has the highest value of electronegativity and the lowest value of electronegativity on the Pauling scale, and what is the range of electronegativity. Based on difference in electronegativity, how to identify polar bond, non-polar bond and ionic bond. And then followed by some practice problems and a quiz. As we discuss periodic trends in the periodic table, means variation of properties down the group along the period, noble gases, hydrogen atom and radioactive materials are generally exempted. We know that down the group atomic size increases and along the period atomic size decreases. It means cesium can be considered as the biggest atom and fluorine is the smallest atom of the periodic table. So cesium has the lowest tendency to attract the shared pair of electrons because of its big size. So it is the least electronegative atom in the periodic table. Fluorine is the smallest atom with the highest tendency to attract the shared pair of electrons on itself. So it is the most electronegative element of the periodic table. As we discussed earlier also, that electronegativity cannot be measured in joules or kilojoules because it is not an energy. It is the tendency to pull shared pair of electrons. So we have a different scale to measure electronegativity. And that scale is called as Pauling scale. Cesium is the biggest atom, has the lowest electronegativity value of 0.8 on Pauling scale. And fluorine is the smallest atom with the highest electronegativity value of 4.0 on the Pauling scale. So it means all important elements of the periodic table will lie in the range of 0.8 to 4.0 on the Pauling scale. This is the periodic table of electronegativity. Cesium has the lowest value of electronegativity of 0.8 because cesium is biggest in size. Fluorine has the highest electronegativity value of 4.0 because it is smallest in size. All important elements of the periodic table are in the range of lowest value, that is 0.8, to highest value, that is 4.0. Down the group atomic size increases, it means electronegativity value decreases. Along the period atomic size decreases, it means electronegativity value increases. Nitrogen is less electronegative than oxygen because nitrogen is bigger than oxygen. Bromine is less electronegative than chlorine because bromine atom is bigger in size than chlorine. So this difference in electronegativity values are just because of the difference in their atomic sizes. Difference in electronegativity causes polarity of a bond. More the difference in electronegativity, more is the polarity of a chemical bond. Based on that, we have three categories of chemical bonds. One is non-polar covalent bond, polar covalent bond, and ionic bond. When the difference in electronegativity is less than 0.5, for example in Cl2 molecule, the difference in electronegativity here is 0 because both atoms are identical. Or in carbon hydrogen bond, the difference is very less, it's less than 0.5. So when the difference is less than 0.5 or nearly 0, electrons are equally shared or there is hardly any polarity. Bond is non-polar covalent bond. But when the difference in electronegativity is more than 1.7, in this case electrons are not shared, but they are nearly transferred. This is the case when metals are bonded to non-metals. Here electrons are completely transferred from metals to non-metals. These are ionic bonds. If the difference lies between 0.5 and 1.7, then electrons are shared but not equally. This kind of chemical bond is called as polar covalent bond. There is a charge separation here, like chlorine here is more electronegative than hydrogen. So chlorine acquires a partial negative and hydrogen acquires a partial positive. More is the difference in electronegativity, more is the polarity of the polar covalent bond. If the difference in electronegativity is less than 0.5, they are considered as non-polar covalent bonds. For example, carbon-carbon, carbon-hydrogen bonds. The difference here is very less. If the difference in electronegativity is between 0.5 and 1.7, the bond is polar covalent bond. Nitrogen-hydrogen, carbon, lithium-carbon bonds, all these chemical bonds are polar covalent bonds. The polarity increases with the increase in difference in electronegativity. The difference is greater than 1.7, then the bond is ionic in nature. In ionic bonds, generally, one is metal, other one is non-metal. And the difference in electronegativity is very large, more than 1.7. In this question, we will identify the polar covalent bond based on the difference in electronegativity, and then we are going to show charge separation as negative and positive, again based on difference in electronegativity. In carbon-lithium bond, lithium is metal and carbon is non-metal. You already know that metals are less electronegative than non-metals. So here there is a charge separation. Lithium is partially positively charged as it is less electronegative, and carbon is partially negatively charged as it is more electronegative. If we check the difference in electronegativity of carbon and lithium, the difference is within the range of 0.5 to 1.7. It is going to be a polar covalent bond. Similarly, in case of carbon, magnesium and magnesium-bromine bond. Magnesium is a metal. Carbon and bromine are non-metals. Non-metals are going to be more electronegative. So there is a partial negative charge on carbon, a partial negative charge on bromine, and magnesium is going to have a partial positive charge on it. But is this bond is also in the range of 0.5 to 1.7? So let's check their difference in electronegativity. Magnesium is 1.2, carbon is 2.5, so the difference is within the range of 0.5 to 1.7. Hence the bonds are polar covalent bonds. Okay, now let's try to understand the polarity of carbon-hydrogen bonds. Hydrogen is less electronegative than carbon, but the difference in electronegativity here is very less. It is 0.4. So it is less than 0.5. It means carbon-hydrogen bond falls in the category of non-polar. There is no charge separation in this chemical bond. Okay, now we'll compare oxygen with hydrogen. There is a big difference in electronegativity. Oxygen is more electronegative than hydrogen. You can check the electronegativity values in the table. Calculate the difference in electronegativity and you can see differences lying in the range of 0.5 to 1.7. This bond is polar covalent bond. Now compare carbon-oxygen bond. This bond is also polar covalent in nature because the difference in electronegativity of carbon and oxygen here is 1.0. Carbon is less electronegative, so it will acquire a partial positive. Oxygen is more electronegative, so it will acquire a partial negative. Similarly here, this carbon is partially positive and oxygen is partially negative because oxygen is more electronegative. No polarity of carbon-hydrogen bond because the difference in electronegativity is very less. It is a non-polar covalent bond. Then again carbon-oxygen, where carbon is less electronegative than oxygen. Then oxygen-hydrogen bond, where hydrogen is less electronegative than oxygen. In this question, we will identify the bonds as ionic, polar covalent or non-polar covalent bonds. For this, we need to review the concept of difference in electronegativity. If the difference in electronegativity is greater than 1.7, then the bond is ionic because the difference is very large. If it is in the range of 0.7 to 1.7, then the bond is polar covalent in nature. If it is less than 0.5, then in that case it is completely non-polar bond. More is the difference in electronegativity, more is the polarity of the bond. If one element is metal and other element is non-metal, then the difference in electronegativity will fall in the range of more than 1.7. Then it is ionic bond. If the difference in electronegativity is negligible or zero, then it is going to be a non-polar covalent bond. Now we are ready to answer questions. Cesium chloride. Cesium is the most reactive metal and chlorine is very reactive non-metal. The difference in electronegativity here is very large, so this bond is ionic in nature. Dihydrogen sulfide. Hydrogen is a non-metal and sulfur is also a non-metal. Sulfur being closer to the noble gases is more electronegative than hydrogen. Hence, the difference in electronegativity lies in the range of 0.5 to 1.7. This bond is a polar covalent bond. Hydrogen. Nitrogen-nitrogen bond is going to be non-polar because there is no difference in electronegativity. Here, both the nitrogen-nitrogen atoms are identical and the difference in electronegativity is zero. Hence, nitrogen-nitrogen bond is going to be non-polar in nature. Thank you for watching this video. In Electronegativity Part 3, following topics are covered with examples and practice problems. Highest value of electronegativity and the lowest value of electronegativity. Based on difference in electronegativity, some questions are done to identify polar bonds, non-polar bonds and ionic bonds. If you want to practice more questions on the same concept, please click on the link given below. You are most welcome to ask your doubts or questions in the comment section of this video. In Electronegativity Part 4 video, we will discuss variation of electronegativity with hybridization of atom, oxidation number and formal charges, and the movement of electrons during resonance due to difference in electronegativity. Some examples will be done to clarify that how the electrons are moving during resonance, followed by some practice problems and a quiz. You can click on the link shown here to go to Electronegativity Part 4. Links to notes and questions have been provided in the description below. Please like, share and subscribe. And do not forget to click on the bell icon to turn on notifications.